Take two. Welcome everybody to MS-DOSX lecture number 8, testing. This is a little bit different from last semester's. And I'll talk more about this in detail as the lecture goes on. But last semester's had demos on setting up specific testing suites for Xcode 3. You'll be doing that either on your own on these machines through the documentation through an optional lab that you can do, or I will be showing you and demonstrating the setup of Xcode 4's testing, and I'll be doing that at the end instead of interspersing. So what I'll be talking about is the testing, setting up testing, what testing is used for, how to do it effectively, how to do it with iOS and OS X. And then I'll be talking about the setup, and the setup is, there's some setup issues with Xcode 3 that you have to be aware of, and I'll touch briefly on those, but for the most part that'll be in the optional lab, and I'll talk about that as well when I get to the end of the slides. So here's an overview, a little bit more about what I was just saying. So you can test OS X and iOS applications almost identically to each other. There's two major categories of testing that Apple and Cocoa use, and that is logic tests that happen at build time and application tests that happen at runtime. One is more of a static analysis, and one is more of a dynamic analysis. And then I'll also talk a little bit about automation, about automating your testing suites that you can run automatically at build time, and also automation when it comes to user interface and gestures, and testing predefined gestures and user interface elements on iOS. So why test? It's really obvious, and a few of these points are very, very obvious. Immediately what comes to mind is to write better code, right? Find bugs. Duh. That's kind of like the baseline for testing, right? And that's what everybody just assumes testing is for. Testing is to debug. That's actually only a small slice of the picture. Testing, as outlined by Apple, and this is also an optional lab, so I'm not going to spend a whole lot of time here. But here are some more reasons for testing. One is to make sure that your software and your applications and your frameworks that you design are healthier, that you are confident when you add or change code or take code away, you're confident in it, and you're not running on a shaky platform that when you're not super confident in it, you have a difficult time writing good quality code and debugging your code as well after the fact. It also helps you design the API, the user interface for developers, including yourself, for people that use your code. It forces you to use your own API. There are so many APIs and frameworks out there that people have written in the dark, and they've got this really cool framework and this package or this library to give you, and you use it and you realize that it's a total pain in the butt to actually use and implement. And that's because the person who wrote it didn't eat their own dog food. They didn't actually use the library and API. They spent a lot of time crafting it, but they didn't spend a lot of time with the interface of it. Testing forces you to use your own interface and go through the whole thing and make sure that not only all of it works, but that it's easy to use. The canonical example of this is another reason for testing is in an mechanical engineering sense. When you build a huge building, you don't build the whole thing at once and then start testing it level by level, right? That's ridiculous. The first 2 levels are screwed up and your whole building is going to come down, right? So you test as you go along, and you test and you build a solid foundation and something that you're confident in, and then something that that you know that you can build upon and isn't fragile and isn't going to start breaking down. Because once you start adding layers, it starts becoming exponentially more difficult to track down bugs. So if the layers are debugged and they're fully tested, and you start adding to it, you'll be confident and it'll work a lot better, and it's a lot easier to debug. It also gives you, this is a bit of a contentious point, but it's also a part of self-documenting code. If you use your own API, if you fully code complete and check your code coverage and check your API, if you hand that library over to somebody with your tests, they can see how to use your API. Having comments in the code are awesome. Having external documentation is better. Having long variable names and long method and class names is great, and that helps towards user of your code, including yourself, especially when you have to come back to it. Hint, hint. You'll find that if you've got test cases written, that you'll also have, you'll basically have a blueprint and an outline of how to use each one of the classes in your API. And then it just accelerates the development pace in generating quality code overall. The cycle for code generation, most developers, when they first think code generation and amount of code generated, is how much code I've written. That's not production code. That's generated code, and nobody's perfect. It's gonna have bugs in it, right? So you have to debug it, and when you debug it, you have to go back and edit your original source. And then if you edit it and you still have bugs, if you're not testing somewhere in that cycle, you're going to find that that loop starts getting larger and larger, and the edit, compile, debug, edit, compile, debug, edit, compile, debug cycle starts to become so long that people that have taken the time and written tests, quality tests, are going to go flying right past you with the amount of production and finished code that they actually have. So some of the subtle differences between OS X and iOS, there's a lot of Apple developer documentation on this, so I'm not going to talk too much about it. But I'm going to highlight some of the important similarities and the differences. So they both can do logic testing and application testing. They both can do testing at build time before your application is running, and they can also do testing while your application is running, dynamic testing. And we'll talk a little bit more in depth about what that entails. But I just want to let you know that they both can do that. They both can test at compile time, and they can test at runtime. On Xcode 3, you can't do application testing at dynamic testing on the iOS simulator. If you want to do, and I highly encourage that you do application dynamic runtime testing on your app. That is stuff that you need to test when your view controllers have come up, when you've started navigating through things, and you need to test a specific, say, table, a scroll view that you want to test. You have to do that on the hardware. You have to have it plugged in. Debugging messages come out on the console. I'll talk about that more in a second. So you'll get the testing messages on the console, but you have to run it on the hardware. In Xcode 4, you can run your application tests in the simulator, which is pretty cool and very convenient. You don't have to download everything. You can run it right there in the simulator. The API is almost identical for the two, but I'll highlight some of those differences as we go on here. So for application testing for OS X, you typically start by testing your model, and this is one of the huge benefits of the MVC design pattern. Is you can test your model outside of your views and your view controllers and your interface display. Since you've got those separated and they're separated by a controller, you can test your model without any of the views. You don't even need all of the Cocoa frameworks, all the UI frameworks and NS frameworks for your displays. You can test your model independently. What's really cool about that too is that you can run those tests before your application even starts. So you can run these tests, and that's how it's set up, and I'll give you a demo of that. You can run these tests while your app is compiling. And it'll kick off, as soon as the object code is generated, it'll kick off a script and start testing while you're compiling at the same time. So you can have your tests running even before you get your application launches. User interface testing, like I mentioned with iOS, is doable, but it's a lot more challenging. And we'll talk a little bit more about that towards the end here. So logic tests and application tests, the dynamic and static tests for iOS. The logic tests, just like on OS X, it's all done at build time. You don't have to run it in the simulator. What's really cool about the logic test too is that it's totally isolated. It's clean room testing, called clean room testing, where you can test your model absent of all of your views and your controllers, and it doesn't matter what state all of your interfaces in. You can test your model at a very highly granular level before initiating all of your dynamic tests and your tests with your user interface. That can be all done in essentially in a sandbox. It makes debugging and fixing bugs that much quicker. Application tests are run at application time. I mentioned that previously. You run that in Xcode 3 on the hardware. You can do it in the simulator with Xcode 4. The nice thing about running it in the hardware, though, with Xcode 4, you have the option, excuse me, of doing either one. The nice thing about running on the hardware in Xcode 3 or 4 is that you can also test the hardware that's specific to iOS devices, like location-based services and the accelerometer and things like that. So this is a super brief overview of Xcode 3 project setup. I'm not going to even demo this because there's documentation and the optional lab covers it. And more importantly, if you're doing a new project nowadays, you're probably going to be using Xcode 4 anyway. Highly recommend it. And it's set up and I'll show you, it's set up to add testing to your project if you haven't set it up ahead of time, which is just a checkbox selection. If you haven't set it up ahead of time, adding testing is a breeze. It's a couple menu selections and a couple clicks. So basically what you do when Xcode 3, you have your project and you've got your targets, right? Usually you've got one target, and that's your main application. So you create a new target in Xcode 3, and that new target is called a unit test bundle. You'll add a framework, and the framework is called the SEN testing kit, SEN testing kit framework, the SF framework. That name comes from, it's derived. Don't need to go into that, but just to let you know, that's the name of the framework, and those are the headers that you'll be using, and that's also the prefix of the classes, ST. So you'll create a new group then on the left-hand side for your test cases. Remember, groups are just a way to organize your source. It's not doesn't create folders in the Finder or in the file system. So it's a way that you can organize all of your testing code into one place. So it's really convenient to make a group for that. Then you just add new test cases, and when you do add a new file, you'll see that there's also a choice for an Objective-C test case class, and I'll show you what that looks like here, what the boilerplate for that looks like here in a second. But that's all you do to add tests, is just add new test cases with adding a new file, just like you would add a new nib or add a new source code file. When you build the target, all your logic tests will show up in the console, in the debugger window. And I'll show you that in Xcode 4 live. Xcode 3 is very, very similar. It just shows up in the debugger, the separate debugger window, not the integrated one in Xcode 4. So there's two different ways that you can set up your Xcode 3 project. You can set up the tests to be interdependent. You can set up your tests to be completely independent, totally isolated, so that you have to run them manually. And some of the pros for that are it's easier to set up your project. If you have bugs in your code and you've written test cases that have problems, and you don't want to forget about fixing something else, and you want to test it, you still have to make sure that the test's complete before your application launches. Some people find that frustrating. Some people find that as a pro where you are pretty much forced to run your tests all the time. If they're well written, they take no time at all. They can run in parallel with the compilation and link time, and they take it takes a little bit more setup under Xcode 3, much less setup in Xcode 4. So without going into detail on the Xcode 3 project setup, there is one thing that you should be thinking about ahead of time, and that is what are your logic tests going to be, and what are your application tests going to be? What are tests that are going to be that you can do at build time before there's been any views and interfaces, and what are the tests that you're going to do while the application is running? States that your application get in from user interface input that you need to test and that you need to check. Creating both of the tests are new targets in Xcode 3, but the application test can be made interdependent, can be locked in with the logic tests as well, so that when you run your application, and it automatically runs the tests as part of the compilation and build cycle. So to set up the logic test setups for iOS, these are the ones that you don't have to run in the simulator. It's exactly the same as OS X applications. You just need to make sure that you're using Cocoa Touch classes and not Mac OS classes, which I used to do all the time. For application testing for iOS, you make a copy of the application. You create a new unit test bundle target. It's the same as OS X and iOS. It's just under iOS, you'll create a new Cocoa Touch class, which is labeled as an iOS unit testing. Objective-C, iOS Objective-C unit test. Sorry, it's been a little while. Something like that. It's akin to the OS X. You'll see it right off the bat. I mean, it's a totally separate file that you can create, and it says testing, whether it's Objective-C test case or whatever. It's really obvious. You can set up the dependency between the two so that just like with OS X, you can set it up to run your tests before your application even launches and while your application is running. And like I said before, iOS application tests have to be run on the hardware under Xcode 3. Under Xcode 4, you can run it in the simulator. All the output appears in the debugger console, and I'll show you a demo of that in a second. So basically, here it is in a nutshell. The testing kit and the way the testing works in a nutshell. There's a test case class. It's an interface. And it inherits from the parent object is send test case is what it's called. The methods are all of your test cases that you want to run. You add an Objective-C test case class, which is what I mentioned previously for iOS and OS X. When you add a new file to your project, you add a Objective-C test case class. This is the boilerplate code that you get. It imports the send testing kit and creates an interface with the name of your tests, and the parent is send test case. All of the methods for the actual tests they begin with the word test. They take no parameters. They don't return anything, so their return type is void. And in the interface, this is what it looks like. This is the interface for your test with your parent class send testing case, send test case, and then each one of your tests are listed there as prototypes, essentially, for your methods. They'll automatically be run by the send testing framework. You don't have to do anything else. It's just as long as you follow these rules of using the send test case and begin the name with test, take no parameters, return type is void, it'll run them automatically. In the implementation, here's what it looks like. Really straightforward, right? Doesn't return anything, takes no parameters, write your test in there. That's it. there's setup and teardown code, and I'll show you that in a second. That you can set up each one of your tests and shut down each one of your tests. That's provided as utility. That also shows up in the boilerplate, and I'll show you an example of that in a second. So there's macros for the send testing kit, and there's a ton of them. This is built on using the same concepts as the assert function. Essentially they're all st assert and then some kind of expression or some kind of condition. Assert true, assert false, assert equals, assert that it throws a specific exception, assert that it doesn't throw an exception, assert that the contents of two objects are equal, or assert that the actual object pointers are equal. There's a ton of them. They're there for your convenience. They've got expressions or variables as their first one or two arguments. Then there's a description that you can put in, a human readable description, so that if your test fails, it'll highlight and show you what you've tagged as essentially a comment for that test. Makes finding tests, especially when you end up with 100 test cases, and you start failing on something early on. It makes figuring out exactly what you were testing for that much easier. And then it can take variable arguments, so you can pass in printf specifiers and then specify multiple objects or multiple variables or values to print out in your description. All of these are listed in the documentation. So, like I mentioned, you can automate iOS testing. I highly recommend that you do that, especially if you've got a really complicated sequence of events that you have to go through. You don't want to have to keep navigating through a whole bunch of sequences to test something. What's going to happen is you're not going to test it anymore. It's going to become such a hassle and such a burden that you're just going to not test it, or you're going to test it very infrequently, and then if you find a bug, you're back to that model where you have to dig through a whole bunch of layers to debug it and to fix it. So there is automated unit testing. I highly recommend that if you're going to build an iOS app that has a lot of functionality and a lot of navigational layers that you investigate this, it's quite a bit more challenging. It's a little bit more involved. You have to write JavaScript scripts that control all the user interface elements. It's very powerful.
Really fun when you get it to work.
It is really cool. It's definitely got a pretty steep learning curve, but the payoff is enormous. So the UI automation reference collection in the developer documentation has a lot more information about this. Instruments is the application that you'll be using, whether it's Xcode 3 or 4. It's a built-in instrument called UI automation. O'Reilly's books also, and I'll provide a link for this, has also got a tutorial on how to set up user interface automated testing. With Xcode 3, I believe, but the concepts are very similar with Xcode 4. So, writing testable code. So how do you write code that's testable in the first place? Slapping tests after you've written all your code onto your code does a huge disservice to you and to your users. The main reason for that is because you know what the code looks like already. You've built on it, you know what it looks like, so your tests aren't going to be general and they're not going to have very good coverage. So writing good testable code and thinking about this ahead of time will save you huge headaches later on. And here's some of the guidelines for writing code that's testable. First, define your API requirements, whether you do it on paper in a documentation or just a comment in the source. Define the inputs, the outputs, and the exceptions that your code can generate. Java has the throws declaration, which runtime exceptions are excluded from that. Java is a step closer in that direction, but and especially if you force Java docs on and generate compiler errors in Eclipse with Java doc errors on, I highly recommend that you start doing this, that you start not only putting a one-line description of what a class does or what a method does, but also define what your inputs are, what the ranges are, what the outputs are, what the expected outputs are, and any exceptions that your class can throw. Write the test cases as you're writing your code, as you're writing your application's code. Who's heard of test-driven development? Yeah? So there's debates on either side of the table about how effective and productive it is. I can say from my own personal experience, I do a mixture of the two. Sometimes I'll prototype and write code and then write test cases and then clean up the original code to make it more production quality. Oftentimes I'll write the test cases ahead of time. I'll show you an example of writing a test after the fact, and how writing a test beforehand could have saved a lot of time for a bug that I recently had and something that I was working on. Check the boundary conditions when you're writing test cases. Check to make sure that if the range of your function is, say, an integer from 0 to 100, that you check 0 and you check 100. You also check -1 and 101. Make sure that those are failures and 0 and 100 work. Testing 50 and it says OK doesn't really tell you anything, right? And you could test 20 and it says yes, green light, your code works. Not really, right? It works for 20, but it's much more important to test the boundary, the edge cases. Also, use negative tests. Also check to make sure that you're handling bad inputs correctly. Make sure that if you have a range from 0 to 100, that you're not only checking 0 and you're not only checking 100, but you're making sure that you fail correctly on -1 and 101. So you want to check those, and you also want to check your exceptions too. Force your code to throw exceptions. Check and test to see that it has thrown that exception. And this becomes really, really valuable as you start doing regression testing. Who's heard of regression testing? What is it?
It's like stuff that should work before, and you have to do stuff to make sure that.
Exactly. So you keep running your old tests on your original code. You don't throw out your test code. You don't start turning them off as you write new code. You keep all of your old test cases around, because they should all be passing. If you write new code or you bug fix something and suddenly one of your early test cases no longer works, and that happens a lot more often when you're checking edge cases and you're checking for exceptions, it's an invaluable tool for debugging and making sure that your code is correct and the foundation is strong to build on it. Write really comprehensive test cases. Don't write just test cases if you have a model, say, that multiply. It's a calculator model, right? And you check add, subtract, multiply, and divide, and that's it, right? You write test cases for plus, minus, divide, and subtract. Well, or multiply, and that's it, right? So you write 4 test cases. Well, that really doesn't help you that much. What if you add parenthesis? Then okay, well, I'll test that. But now, what happens with large expressions with multiple parentheses? Do you handle that correctly? Well, that's the whole point of layered testing. Write your low-level, highly granular tests, but as you're putting those together, start writing more and more meta tests that test more and more functionality of your program. If you write it too big of a test, and this happens when you don't write tests at all, you just run your application to see if it works, right? Which doesn't really tell you anything. If you compile it, you say, hey, it compiles, it works, done, ship it, right? So this is the same thing as writing a test at the very beginning that says, okay, does it start up and does it shut down? Oh, yeah, well, that's great. That doesn't really tell you very much, right? So write your granular tests, write tests that are layered, where you have multiple tests doing you have a test that runs multiple tests, and then tests on top of that runs multiple tests of those. An example that the developer documentation is create an array like an NS array, fill it with objects, remove them, double check and make sure that the array is still the same as the array is what you expect it to be, that the contents are what you expect it to be. And I can show you an example of that too. Every time you fix a bug, write a test case for it. That's the best way to not only check to make sure that your bug fix is correct, but also for regression testing to make sure that the bug doesn't creep back in again later on. So a really good rule of thumb is if you're totally test averse, and I'll tell you why that's a really bad state of mind to be in a second. At least write tests to check to make sure that your bug fixes are correct. Then you can run them and make sure that they stay fixed, and that if you change something later on, that you don't break one of your earlier bug fixes. As you start adding more and more patches because you're not testing, or you're testing after the fact and you're doing a lot of bug fixing and adding a lot of patches, as your code starts becoming really, really fragile, and you start building up these layers on a really fragile layer, and then you start to have these enormous edit, compile, debug cycles that kill your time estimates on your overall project. So today's lab is optional. In Xcode 3, if you look up unit testing, there's a tutorial on how to set up and run user testing, unit testing for a project. I'm going to demo for you though on the Xcode 4 setup. It's very similar, and I'm going to show you what some of the output looks like in real time. I'm also going to give you a real life example, a stripped down real life example of something that I ran into the other day. We'll have the links for the projects if you're having trouble getting the project links that they have, the framework links in the documentation. We'll have links to those. I've got those downloaded. The ST assert macro references in that documentation, and then there's more. We'll provide more links that have the O'Reilly's unit UI interface unit testing. Kevin's going to talk about the homework after we do the demo here. So before I start the demo, questions. I know that I skipped over a lot of the Xcode 3 project setup really fast, and I'm sure it just went right past you. I kind of expecting that because building new projects now, if you're doing some really heavy production work, you're most likely going to be using Xcode 4, and I'm going to demo that for you now. But also because today's optional lab has you set all of this stuff up and go through step by step and do this anyway. So it's not really worth spending a whole lot of time on. It's much better for you to get your hands dirty and see what actually using it is like. Yeah.
I think on the earlier slide you said Xcode 3 doesn't allow for iOS testing.
So iOS testing, like OS X testing, is broken into two major categories: runtime testing, which is the dynamic application testing, and logic testing, which is build time testing. iOS will let you do the logic tests without the hardware. You can do all the logic tests, and I'll show you an example of what that is. You can do all that with the simulator because that all happens at compile time. The application, the dynamic stuff, when you want to test your user interface or you want to test some of the device-specific hardware, you have to use hardware. You have to use the hardware for it. You can't. It won't run on the simulator. Yeah.
What are the advantages of the JavaScript testing over the built-in or whatever?
So the user interface automated testing is another component in the testing toolbox. It's not as a replacement of. It's an addition to. So not only can you test your code and check to make sure that all your memory is good, your object allocation and deallocation is good, but you can also test specific user interface functionality.
So why is it written in JavaScript? Like, why didn't they just reject it?
I will defer to the documentation for that. There's actually a pretty good reason for it. But to be honest, I haven't used it enough to really to know the benefits of why they made that call in the first place.
Well, I mean, I've used it a little bit, and you don't actually have direct access to like all the views and stuff that are on the screen. You just kind of have a bunch of. You basically can just touch the screen anywhere you want, and it will detect that there's buttons, and you can. But it doesn't actually inject into the code, which is how which would that would work if you. Not explain this very well. I actually don't really. The short answer is I don't know. I believe there's an Apple internals framework that uses Objective-C directly because they can attach directly to the process. That's an internal private thing that we can't do. But JavaScript is just it's basically kind of like making Ajax calls, where it's just kind of not Ajax. I don't know. It's basically just simulating multiple touches, and that's easy to do with JavaScript. Because JavaScript already has ways for you to simulate interacting with a web form, for example.
That's right.
So it's basically just doing that.
So a plea to start testing and a warning about not testing. This past couple of weeks, I played 2 games and used one utility that both crashed after about half an hour. One of the games didn't crash until about an hour and a half into a mission on every single machine that I tried it on. I'll never buy from that developer again, ever. I mean, it's so frustrating. And it's not worth my time and my money, right? I paid $60 for this game, and they should test the thing, right? And it's a systemic problem because it happened on all different machines. I made sure that it wasn't like a graphics card issue. So Apple's made great strides in this in terms of providing the App Store and making sure that you kind of run the gauntlet before your app goes up. Unlike another operating system provider, your app has a much better chance of remaining more bulletproof and crash-proof than some other apps that are out there for another operating system. However, if you think about it, when you open up your app or open up somebody's app on the App Store, you also see other apps from this company or other people bought these other apps. If your app crashes, and on iOS, and especially on iOS, when you don't have any error messages or anything, it just goes back to the home screen, and I know you've seen this happen before. If that happens, users are going to say, that's it, I'm done. I don't want to buy, I'm going to find something else because there's probably another app for it. There's probably something else like it. And hey, guess what? There's all your other company apps are listed right there. If you've demonstrated that your app crashes a lot and it's obvious that you haven't tested your app, I'm going to guarantee you that people are going to see your other apps and think twice about picking any other apps that you put up there. Test, 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 test. I'm a huge fan of testing and test-driven development and making sure that your code is bulletproof as possible. Let me show you a little bit about how I do that and how I can do that with Xcode 4. So what we'll do is we're going to go and we're going to go to Bouncy from, let's see, where do I have that? We're going to go to Bouncy from the lab. We'll open it up, and we're doing this all with Xcode 4. So we'll run it. We'll run it just to make sure that the way that the project is set up. What I'm showing you here is adding testing after the fact. I advocate that you start testing very early and soon, and set up your project to test ahead of time. And I'm going to show you that. I'll show you that in a second. This is if you haven't added testing to your app, how to start adding that and how to start using that. So what we're going to do is we're going to test the model. We're going to write some logic tests to test the model. And so what you do with OS 10 with Xcode 4 is I want to add a target. And if you look under here, either if you're iOS or OS 10, it's the same thing. OCUnit testing bundle, and we'll call it, I usually call it just the product name and then add test on the end. So now we've got this, you see this little Lego piece up here. Actually, this is probably, the font's probably pretty small. It's probably hard to see, but regardless, you now have a target that if you look down here, it's created a group of supporting files, including that header that I was talking about. So here's the boilerplate code, and bouncy test is our interface, inheriting from send testing case, and here's the boilerplate code for the actual implementation. So setup is all the code. It's going to be code that's going to be run before every one of your tests. So this is a great way to set up, like if you've got an object that you need around, and I'll show you an example of that. If you got an object that you need around for every single one of your calls, this is where you can put it instead of having to copy and paste a whole bunch of code. Same thing for teardown, for cleanup, and then here's an example of one of the tests. So the boilerplate code shows you, just so that you can see when you build it, you can see and make sure that the test framework is actually running. So stfail is one of the macros that comes with the send testing toolkit. It just fails. It's like an assert false, and it takes a description string. So this may seem trivial, but this stfail is actually really handy. If you've got like a bunch of conditional statements that say return, that leave from something, and you want to check to make sure that it's hit one of those conditionals, you can throw an stfail at the end and make sure that it's actually caught one of those conditions. And if it goes all the way through the conditions, it's not caught, then it fails. So what we're going to do is, if we run it, just as it stands, it runs like normal. This is remember, this is for Xcode 4. So if you look under the in the menu, there's an option to test. So what I'm going to do is I'm going to switch to the testing framework and run test. Or sorry, build test. So I build it, and if we look in the debugger output, we can see right here that here's the method that we're testing. Test example. The first example 1 failed. This failed for obvious reasons. It counts the number of failures in the class, tells you how long it ran. Performance we'll talk about later, and then gives you an overall, here's how many test classes I ran, how many failures and successes I had. So let's make our test example now. Let's test the model. So what we'll do is we'll import the bouncy model, and we won't use setup and teardown for right now, but what we're going to do is we'll create the model. If you guys see syntax errors, you can point it out, but logical errors, I'm going to be doing it, so don't throw them up. So we need a boundary to initialize the model with. So we're going to create a rectangle that's bounds. .512 by 512. And we'll use st assert not nil model and the model was nil. Alec and nil. That's our description. We're not going to pass any parameters in here. Build it. Sorry, test it. So this will happen a lot of times as you start initially writing your test. You'll get these linker errors. You have to remember that this that you're testing is an actual target. It's a separate target. Who's used a multi-target project? Who's had a project that's had multiple targets, different applications, different settings for different applications within one project? Okay, nobody. So you can set up in your project, you can set up different targets so that you can build your application in different ways. This is really helpful if you're going to build like a universal application. Xcode 4 makes this much, much simpler to do. However, you have to be more cognizant of what's being done in each one of these targets. So if we look in our application and we go to our build phases and we go to the compile sources, we can see we've got main, the app delegate, the view controller, the view, and the model are being compiled. If we go to our test, we see that just the test code is being compiled. So obviously we're going to have a linker error, right? We're not compiling and linking in the bouncy model. So we need to add that. So there's two ways to do that. Either we can drag it in over here, which is really straightforward, or when you switch to, when you're in the source code view, if you click, so normally you've got the help over on the right hand side. If you click the file inspector, you can see all the targets that file is in. So we'll turn that on here. We'll say, all right, we need to include this in the build phase for the testing target. So we'll build it, and it runs, and we had one test, 0 failures, 0 were expected. And so that's good. So we know that we can call it with a sane rectangle. Well, let's try test bad. We'll keep this, except we're going to pass in negative bounds and see what happens. So 2 tests ran, no failures. What does that mean? What does that say about our code? I'm passing in a rectangle that's negative width and height. It takes bad input, right? So our code is busted, right? It's not. And if this is being done dynamically, like let's say when you resize the window, it creates a new model with a new bounds. These numbers that can be passed in this rectangle isn't necessarily static. It could be dynamic. So you can get a whole range of inputs. So our model is broken. Our model needs to make sure that if we initialize it with a negative boundary, that it doesn't allow us to do it. So I'll leave that as an exercise for the reader. But what we can do basically is return back null if the rectangle is invalid, or we can assert that the rectangle is a valid rectangle with a width and a height. And if it returns back null, then we'll get a failure here. But if we say, all right, our code, our API says if we pass in a bad rectangle, we get a null value back out again. So that's how you can test that there. What I actually really wanted to get to was that I want to make some time to show you is a real world type example of something that I had happen to me the other day. So I'm going to pare this way back, but when you're setting up your Xcode 4 project, bad cache. So when you set up your Xcode 4 project, you have some options down here. One of the options is include unit tests. So that sets your project up with everything. It puts the frameworks in. It puts the boilerplate code in. It puts all the dependencies together. So highly recommend. This should actually be on, and you shouldn't even be able to turn it on and off all the time. So we'll create a new project. So here was what I was trying to solve. So I have a project that has a whole bunch of table views. that have a whole bunch of cells, and those cells are a combination of images and text fields. I want to cache those images. I don't want to load and create new objects for each one of those images, because I could potentially have table views that have hundreds of elements, and I don't want thousands of images sitting around in memory. So I wanted to come up with a cache for it. So what I did was I made a new model, a new cache model, and this is kind of greatly simplified, but model cache. But this is getting kind of to the gist of what of how to debug effectively and how to write tests effectively. So what we'll do is create a new cache model, generate it, and our cache is just going to be a mutable dictionary. That's it. That's all our cache is going to be. So when the interface, so when we are initialized, when we are initialized, what am I doing? Did I put this in the header? Huh, that was weird. It generated odd boilerplate code. Sorry about that. Super init. Cache equals ns mutable dictionary alloc init with pass. Thank you. So this init with capacity is just kind of a convenience method that just sets aside in a hash table 100 entries. We're just going to do that because we're going to fill it with 100 objects. But it's not really necessary because the hash table grows dynamically. And then, of course, when we're all done with it, we want to release the, oops, what am I doing? So two quick methods: add object, add object to add to cache object using key, and that's just cache add. Oops, value for key. Oops, what am I doing? Set value. Set value object for key. So just a hash table. That's all dictionary is. We're going to set the key that we're just going to pass in a string as a key, and we're going to associate an object with it. That's it. And then of course, get from cache using key. And that's just return cache value for key. That's it. Pretty simple, right? So let's do this we'll do this in our app delegate just as demonstration purposes. So what we're going to do is we're going to import the cache model cache, and we have a model cache, our cache, and our cache equals model cache alloc and for index equals 0, index is less than 100, index plus plus, really gross hard-coded stuff, but this is just for demonstration purposes. So we're just going to fill it. We're just going to fill it with objects. Just empty objects. We're going to allocate some memory for them, but we're not going to put any. We're not going to put any values in there. And then we're going to call our cache, add, what did I call it? Oh, I didn't put them in the headers. Didn't put our methods in the headers. Sorry. So our cache, add to cache our object using all right, well, let's make a key. So ns string key is an ns string string with format of, well, just the format of this string is just going to be the number, the index number. So it'll just be the string 1 for our first object, the string 2, and so on. So we'll just keep it really, really simple. So we add it to the string pointer. We add it, and then we do some stuff with the cache, and then of course we're all done with the cache. So we do our cache release. So we run it, doesn't really do anything interesting. Starts up, shuts down. No really big deal, right? But when I run this using some instrumentation, and we'll talk about this when we do performance and stuff later on, I get a whole bunch of leaks with this, right? This is very, very stripped down, so this is pretty obvious. But when you've got a whole bunch of nested stuff, especially if you haven't been testing it as you go along, these kinds of things start to be really, really difficult to track down. And I found that I was getting with my cache, I was having a whole bunch of, I was ending up with a whole bunch of memory leaks. So it's pretty clear, it's pretty obvious here, right? So what's the problem? Yeah, so we're adding a whole bunch of objects, but we're not deallocating them. So it was very, very, very late, really no excuse, but anyway. So I thought, okay, well, what I need to do is in my dealloc method, I need to release all of the objects. I need to make sure that I get rid of them. So Objective-C 2.0 has got these really fancy enumerators. So I'm going to iterate through all of the keys, the object to release in our cache. So that'll iterate. This will iterate over all of the keys in a dictionary, an NS mutable dictionary, and we're just going to say the object to release, and run it. Oops, I'm going to respond to count to collection. Oh, oops, sorry. So essentially what I did was I had inside my dealloc to make sure that I got rid of all the objects. This is actually this was actually in a whole bunch of different places with image files. So this is a little contrived, but I want to show you an example of debugging and how you can test and find these things. So when I run this, just as it stands, I get a bad exec access. and it happens in NS application main, which since this is being called in our app delegate makes sense, but isn't really that helpful, right? So to the rescue. Remember the diagnostic stuff that we have available to us in Xcode 4. So what I'm going to do is I'm going to turn on our memory, some of our memory checks, especially this one called zombie objects. Zombie objects are what? Yes, sending messages to an object that you've already released. So I'll run this again, and I get the same thing here, except now I'm told that I'm sending a message to an already deallocated instance, and it's happening in here. Does anybody know what's wrong? So I'm iterating over all the keys in a dictionary. And then what do I want to do? I want to get rid of the objects that are associated with those keys, right? What am I doing? I'm releasing the keys, right? And which are strings that have already been released. They're already gone. So I don't want to do that. This should be is, but hey, it compiles, right? That should be a big hint right there. So we're going to do cache value for key, and we're going to get the object back, and then we're going to release it.
That might actually.
Yeah, this actually does.
That's a key value coding.
Oh, is it really?
Yeah, value for key is the key value coding.
What's the?
Object for key is
Thank you. That we'll talk about that with that's next time. That's with bindings and stuff, and it runs and works correctly. So if I decided well that I'm getting these zombie objects, and so I need to figure out how to release it, but I'm not really sure where to release it. So this is probably not the best solution. So you might be running through all these things and you think, hey, you know what? I have a great big frickin' sledgehammer that I can use, and just use automatic reference counting, right? It's magic. It takes all of this stuff out of my hands. I don't have to worry about it anymore. So let's go in and we'll turn on automatic reference counting. And we want it for this, and we have to pre-check, okay? Now imagine this is a huge project. So it's gonna go through and pre-check all of our source code and tell us whether it can actually turn it on or not. Okay, so it's going to change this assign. This is a interface builder assigned to an unsafe retain. Okay, whatever. Okay, you know best, right? So then we'll go to our app delegate. Oh, cool, look, our dealloc goes away. We don't even need our dealloc anymore. Cool, and we don't need this release anymore. Much cleaner, right? And we'll go to our cache and we look and we say, okay, yay, we don't have to release. We can just, we get a reference back out. We're not doing anything with it. Okay, whatever. So that means that's probably wrong just to begin with. But hey, we don't have to call cache release or super dealloc. Okay, cool. So, snapshots. All right, well, yeah, sure. We'll make a snapshot so that we can come back to it if we want to. And we run it, and it works exactly the same way with automatic reference counting. Did I fix it? That doesn't do anything, right? So we actually don't even need this dealloc method anymore. Did I fix my original bug? Imagine this is way more complicated. That these are, and this is actually the truth, that these are image cells within within text view cells, within a table column, within a table, within a scroll view. So you turn on automatic reference counting, right? Because it's magic, and it takes, and you don't have to worry about it, right? Well, did I really solve my problem? Sort of. Now I have to work my way around it, right? What if I have a view that has 10,000 objects in it, that 1,000 of them share an image file, so I want them cached, but I want to have multiple documents open, and they may need to share across. What if I want to write out old ones that I haven't used anymore? So I guess I could use reference counts, but I don't really have control over what's going on anymore. I can't do specific stuff like write things out to the disk or flush things when I don't need them anymore, right? Automatic reference counting doesn't know anything about the logic of your code. All it knows is when it's safe to do a retain and release. But it doesn't tell you anything about your performance or the way your code works, right? So automatic reference counting is great and it's awesome if you plan for it ahead of time and you know what you're doing. But if you don't know what you're doing and you use it and it's a magic hammer, you have the potential to have a whole bunch of bugs like this and not really understand what's going on. And then if you have performance issues later on, you'll have much less of a chance of figuring out a very easy, quick solution. And you start patching around automatic reference counting, which is just a whole nother nightmare. So what we can do is let's test this thing instead. Let's make sure that, let's actually go back to our pre-reference count version. Restore it, make sure that it puts everything back. Yes, good. Okay, good. Go. And go. Yes.
Question. So how did you find out like which line is crashing from that?
So if you don't have it in your application delegate, if you've got it like in your views or things like that, then the zombie checker it'll show you the exact line where it's happening. Instruments is even better at doing that, and it'll even show you what the contents of the memory and everything is. Yay, crash on demo. We'll talk more about that when we start talking about performance and stuff.
You get actually like line number on the console or something.
It'll actually open up the source code file and show you like here's where you're actually sending the release message. Huh? I'll bet you it's something else I got going on.
No, snapshots are notoriously bad feature.
Oh, good.
They work, but if you can get a snapshot restored to work, it's kind of a miracle.
Huh? Because I had a couple of them work this afternoon. I was testing this to make sure.
Here's the beach ball makes you feel like it's part.
Woohoo! All right, so let's go to our tests, and in our test example, let's just pull this stuff out of the app delegate. I don't even care about that anymore. So we need the header file. We can just pull it out of here. We don't even need this in here anymore. Oh, this actually will show you the Let me see if I can do the if I can get it to show you if I can show you an example right here of the sending to a zombie object. Am I even calling the alloc on it?
Are you running test?
Oh, no. Oh, so it's running the application afterwards. And anyway, I'll show you a better tool for that later. So we could write a test for it ahead of time and find these things much sooner. And then you check by checking. We can do a test test create and retrieve. Oops. And what was the failure? Oh yeah. So this is just test create and receive. We want to make sure that ns log the object from our cache get from cache using, we'll just use the same string here. So this is really ugly, kind of hacked together code, but all I'm doing basically is adding 10 objects to our cache, and then retrieving them, just printing them out, and then here's the perfect place for st assert not nil this object. Our object. The object for key %at was not found. The key. So what we'll do is we'll hoist this out of here, and this is we're going to call this our object. This object, our object is that. The key first. So generate the same key, pull the object out of the cache, log it, and if it's nil, say that the key couldn't be found, and then release it. So under the product menu, I want to do test, and it's tested. It's run 2 tests, 90 failures, because why? They tried to pull 100, added 10 objects and tried to pull 100 out. So we'll fix that. We want to make sure that our tests are correct. So we had 2 tests with no failures, and test, create, and bad retrieve. Let's add 10 objects and then try and pull 1 back out. This is an example of testing and showing you that it's being done at compile time, as opposed to the app isn't even running right now. I'm able to test the model totally independently. So here's what the description line is. Here's the failure in your test case. Here's the exact line of it. It says that our object shouldn't be nil, and here's our description string right here. The object for key number 10 wasn't found, which is exactly what we've got, right? 0 through 9 are our keys for the 10 objects that we've got in there. Cool. Question? Yeah.
If you wanted to use the debugger while you're in your testing files, how would you do that?
Yeah, absolutely. So let's say now we want to make sure, we want to check and see if we can figure out what's going on here. So I'll just set a breakpoint, start the test, and the debugger drops right in. So here we are right here. Step over, we take a look at our key. Here's another handy thing that I don't think I mentioned last time. If you right-click on something in one of your variables and then do print description, it'll send out the GDB, it'll send out the description string. So especially if you have description strings that you've created for your objects, this is a really handy way to see what's inside. Like here's our cache. Let's print the description of it. Well, that's not too helpful, right? Because we don't have a description for it, but we do have a dictionary in here. So let's take a look at what this dictionary says. So there's the contents of our dictionary right there. And it's a CF string is the key, and there's the contents, and those are all the objects right there. And then we can just single step through and watch every single one of these things. So use the debugger just exactly the same way as you would when you're running your application. Cool. Questions? Apologize for the length on that. Hopefully that was beneficial, and that you at least get a kind of an overview of the tools and some of the really powerful tools that are available to you. These tools, though, these after-the-fact tools, can be really challenging, and I've been doing this for a number of years, so I've gotten pretty good at the debugger, but I would much rather spend my time writing code, and if I have to spend a tenth of that time writing test cases and making sure that my code works correctly, I'll do that rather than writing a whole bunch of code and then spending 10 times as long having to debug the same code and run through the same series of events over and over and over again to try and get bugs to reoccur, especially when you have memory bugs. That's why these boundary cases testing is really, really important, because when you start having memory corruption bugs, and an object-oriented environment is no safe ground. It's not safeguard against memory corruption bugs. When you start having them, and you trust me, you will with anything but a trivial project, it starts to get really, really difficult. And if you've created a bunch of test cases ahead of time, especially check your boundary conditions, and check that you're catching failures and bad inputs correctly, it goes a long way to mitigating that time. Cool. Eichten.
Okay, so you guys have a homework assignment. It's up on the website now. It's due not this coming Friday, but the following one. It should be pretty straightforward. It's basically it's really open-ended. It's just write some test cases for either one of the labs that we've done so far, or a lab you're working on, or write test cases for your final project and do some TTD. So really, it's pretty open-ended. Just kind of write some tests. Yeah. And then I have attendance again, so make sure to sign in before you leave. That's it.
Cool.